the binomial experiment homework. I'll do some of these for you. Now, first off, for a binomial, you have to remember the probability of success never changes. Okay? It's always the same. So on this one, they talk about landing on B 3 times in 5 spins. Well, this is 1/8 of the circle. So the probability of event B happening is always, and it's never going to change, 1 in 8. That's the probability of B always happening. It's just the way it is. You do enough of these, you do 1,000 of these, you should get that it happens 1 in 8 times. It's a rule of large numbers. Anyways, I have an exactness here, and I'm telling you on these to be writing down the formula. For exactly 3 times, the probability of 3, and this would be successes, is going to be, we're doing 5 spins, this is N, this is X, and by our formula here, the probability of X successes is going to be NPX, P to the X, and then 1 minus P to the N minus X. And P here is the probability of success. So anyways, probability of 3 successes is going to have to be 5, and I don't know why I said P, C, probably early in the morning, 5C3. Probability of success was 1 in 8. We want 3 successes out of 5, and this guy is going to be 1 minus 1/8. And our exponent here would be 5 minus 3. The 1 and 2 ones really threw me off. So we're looking for 1/8 and 7/8 and a 3 and a 2, because 5 minus 3 is 2. They're not too hard. I'll look at 4. The spinner below is spun 5 times, was probability to land in the green area exactly 3 times. So the probability of being green is going to be 1 in 4. Every time. So let's just do this. We're going to do 3 of 5. So the probability of 3 successes is going to be 5C3. The probability of being green is 1/4. We raise that to the 3rd power because it gets raised to the X. And then here's 1 minus 1/4 to the 5 minus 3. And they actually want us to figure out what this is. And for some odd reason, I feel like doing a little bit of this one by hand. I don't want to just push buttons in a calculator. I mean, I guess I could, but 5C3 is going to be 5 times 4 times 3 times 2 times 1. And you may not remember the combination formula. It's n factorial over n minus r factorial r factorial. So here's n, here's r. And so the bottom is going to be 5 minus 3 factorial times 3 factorial. And then we just figure out what it is, right? Anyways, we have our 5 times our 4 times our 3 times our 2 times our 1. And we have 5 minus 3, which is 2, right? 2 factorial. 2 times 1, and then 3 factorial times 3 times 2 times 1. Gone. And 5 times 4 is 20 over 2, 10. So this piece becomes 10. If you take a quarter and you cube it, 1 cubed is 1, 4 cubed is 64. This piece right here becomes 1 minus a quarter is 3/4. And we have to square it, so it becomes 9/16. And then we just clean up the fractions a little bit here. Let's see here. I know that these two are even numbers. So both of those will by 2, so that makes that a 2 and that makes that an 8. And that's going to make the math a lot easier on me. I hope. I also see another even number. Gone, that becomes 1/32. And I think that'll probably do it. but I guess it probably reduces down some more. But let's see what happens. 1 times 1 times 9 is 9. 32 times 8 is going to be 256. Which is not an answer choice now, is she? Nowhere near close to an answer choice, so where did I mess up at? On 64th. I'm a little confused here. What did I do wrong? This is some New York region stuff out of New York. The odds that it's messed up are slim to none. Okay, so I agree with my first cancellation. 5, 8. I guess I messed up there, huh? Yeah, that's where I messed up. What'd I do? I wrote a 2 out there earlier, didn't I? 5 times 9 is 45, and then 64 times 8 is 512. So, 45 and 512. And I would have been happy if you would have pushed that in the calculator. Like, that's the main thing, is you show the setup. Because on your EOC, this will either be where you have a calculator, or they will write out the formula for you to pick it out. They'll do one of two things. So we got 5, choose 3. And the state of Tennessee might be using a slightly different notation too, which is worth talking about. I wish I would have realized it in your notes. They shouldn't be, but they might be. I don't think they will. But I would have been happy if you would have just wrote it out and push buttons. Would have been a lot quicker, right? All right, so let's do one of these. These have, it says in instructions you can use a calculator. So, lots of ways of using a calculator, but I do want you to write it out. So on calculator, you're going to be using normal PDF for exactly, and normal CDF for things that don't. Okay, so this will hopefully be a little easier. So I'm going to do number 6. Number 1 is the betas win all 4 contests. Now it doesn't say exactly 4, it says they win all 4. That's going to be a normal, I don't know why I'm saying normal either. Ugh, I need to wake up. It's binomial. Normal CDF and PDF are something else, aren't they? So anyways, the betas win all 4 contests. So they're going to win all 4. This means that they could win, well, it's going to be exact. It's exactly 4. So we're going to do a binomial probability distribution formula. The teams compete 4 times a season in each contest and winner. Now, the probability of the alphas beating the betas is 3 in 5, which means that the betas is going to be 2 in 5, okay? The teams compete 4 times a season, so there's going to be a 4. 2 in 5 is your probability. We're looking for 4 successes, right? Exactly 4. And that should be how it lays out. Let's pull up TI-84. This is under second vars. You're looking for binomial probability distribution formula. And it's got your trials there. There are 4 trials. The probability of success is 2 and 5, and it'll convert it straight to a decimal. It should say 40% or 0.4. Well, it didn't. And we want 4 successes. So 0.0256, pretty small there, isn't it? Or 16 and 625. All right, choice 2. Each team wins 2 contests. So this is going to be the probability of the alphas winning 2 plus the probability of the betas winning 2. So we do have to realize that. So for the alphas, we have 4 trials. Their probability of winning is 3/5, and we're looking for exactly 2. For the betas, still have 4 trials. Their probability of winning is 2/5, and we want exactly 2. This is what I'm typing in my calculator, all right? And that's what I said you could do. Second vars, binomial probability distribution formula. The alphas have a 3 in 5 chance. We want exactly 2 successes. Now watch what I'm going to do. I'm going to hit plus. I'm going to arrow up here. And I'm going to change that from a 3/5 to a 2/5. There we go. 0.6912. And can we convert that to a fraction? Because fractions are beautiful. I thought it would. 432 and 625. All right. I don't want to do that one. Oh, at most, by the way, at most one head, you can do this with a probability of 0 plus the probability of 1, or you can use binom CDF. We have 4 trials. The probability of getting heads or tails is 50%, 1/2. And at most 1, you could do it like that. So pick your poison on that. It doesn't really matter. Let's see, I don't want to do that one. I want to save that for y'all. Here's number 9. My end of course math test was way harder than I expected. I had to guess between A, B, C, and D on all 60 questions. There's about 60. Is this a binomial experiment? Oh, it most definitely is a binomial experiment. Yes. Since guessing, the probability of success is always, and it's A, B, C, D, 1 in 4. It's always 1 in 4. The cutoff to be a level 3 is to score at least 60. Now notice the wording, at least 60. Okay, that's a big deal. So let's figure out what 60% of 60 is, and it's going to be 36, but you know, 60% of 60 is going to be 0.6 times 60, and that's going to be 36. Now, this means that I can get 36 questions right, 37, 38, 39. See, it's 36 plus 30. It's the probability of 36 correct, plus the probability of 37 correct, plus the probability of 38 correct, dot, 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 plus the probability of 60 correct. So, you don't want to do that. What you want to do is realize that at least 60% is the complement of at most, or I'll say it's not, sorry, that's of at most 35. Okay? Question is correct. So what we're going to do is and the reason we're using at most 35 is because it's easier. The binomial cumulative density function, it finds the cumulative probability all the way up to the desired number of successes. So since it's a complement, the probability of at least 36 is going to be 1 minus the probability of at most 35. All right, that's the fun part. So we're going to do 1 minus binom CDF. And we have 60 questions, so 60 trials. The probability of any given success is 0.25, and then 35 is going to be what I do. So let's see what that is. And these are tricky for some kids, because some of y'all, God bless you, you just don't have it. Second bar is binomial cumulative density function. We have 60 trials. Probability of success is 0.25 or a quarter, whatever you like, and at most 35. Notice I use the C. The C is for cumulative density function. And it's pretty slim, isn't it? Like even if you multiply it by 100, the calculator's still not going to do it. That converts it to a percent. But it's teeny tiny. There is absolutely no way it's going to convert that into a fraction. So there's 8 zeros before that 9. Tiny, isn't it? You see if I can drag this to the left so you guys can have some room to see what I'm typing. All right, so what do I have here? I equal 0 point, I need 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 973. And that's not even a percent. That's just what it is as a number. All right, the cutoff to be so if you're just sitting here randomly guessing, you're not going to be a level 3. I hope you understand that. It's not going to happen. You're just SOL, kids. All right, cutoff to be a level 2 is 35%, which is 21 or more correct. What was... I don't know why I did that somewhere else. What is my chance of success? So to be a level 2 or more, I understand that this is going to be the complement of at most 20. So the probability of 21 correct is going to be 1 minus the probability of at most 20. So 1 minus, because we're doing complements. This will be 1 minus binomial CDF, cumulative density function, 60 trials, 20 successes, and I put that in the wrong spot, didn't I? 0.25 for the probability of success, and then 20 successes. This one stands a decent chance. It's not going to be near as bad as the other one. So I'm just going to highlight old work up here. Change that 35 into a 20. Be done with her. Not impossible. Little, almost 5%, 0.0541. Or a 5.41% chance. It does happen. Kids guess and they test level 2. It happens. I've seen it numerous times, sadly, but they're guessing. The state thinks I'll test level 1, which is at most 20. What is the probability they're correct? Well, we actually did most of that work. At most 20 was part of this previous problem. It's a binom CDF 60, 0.25, 20. And it's going to be up there. You can more or less guess your way into level 1, which is why it's called level 1. It's as low as you can go. But some kids do really, really bad. Like they're like, if there was a level 0, that's what they'd be. Let's see, let's pull that up. Move my little cursor forward and delete some stuff. Delete, delete. Should be around 94%. 0.9459. or 94.59%. All right. Let's do 11 and 12 and save the rest for y'all. 5 dice rolled. How many different outcomes can there be? This is the fundamental theorem of counting, or it's the fundamental counting theorem, which is worth talking about. It says if event A can happen M ways and event B can happen N ways, then there are M by N ways, both, or M by N is ways, let's say groupings or combinations of events A and B. It's fundamental counting theorem. So 5 dice are rolled. Now, I guess I should have said it was a 6-sided die, but it's a 6-sided die. How many different outcomes can there be? Well, each one of these, each die has 6 outcomes. You know, I could roll a 1, a 2, a 3, a 4, a 5, or a 6 on any given ones. So it's simply 6 times 6 times 6 times 6 times 6 times what, another 6? Which is going to be 6 to the 6, which is just a gigantic number. It's not anything I ever bothered to memorize. Perhaps I should. I always say memorization leads to understanding. 46,656. Oh, 656, right? 656. There you go. And then the last one here is how many distinct ways can letters of Alabama be arranged? There's a formula for this. It's n factorial over n1 factorial, n2 factorial, n3 factorial, dot, dot. All right, so how many letters do we have? We have 3, 7, so 7 factorial up top. A happens 1, 2, 3, 4 times. 4 factorial in the bottom. L only happens once, B only happens once, M only happens once. So it's 7 factorial over 3 factorial, and we could mention these, but the reason I don't worry, okay, so I need to spend some time on this. Technically, it's 4 factorial, L happens 1, 1 factorial, B happens once, 1 factorial, and then M happens once, 1 factorial. Whoops, 1 factorial. 1 factorial is 1. That's why we don't talk about it, okay? This is the only thing that matters. It's 7 factorial over 4 factorial. And I feel like doing this by hand. 7 times 6 times 5 times 4 times 3 times 2 times 1. And that'd be sitting over 4 times 3 times 2 times 1. Cancel, cancel. 7 times 6 is going to be 42, always has been. 42 times 5 should be 210. 210 ways you can rearrange Alabama. And that is where I stop on the 12.5 work. There you go, boys and girls.